To calculate the derivative of f of x equal to x is for n, the domain for this function is the set of all real number, and that is the function is defined on the set of all real number, and the point x, the value of the function at the point x is f of x. This point is a real number on y-axis because the function is defined on the set of real number, and this point f of x is denoted by y and can be measured from x or n. And at the small increment del x in the independent variable, when we add del x, the small increment in the independent variable with x, the next point will be x plus del x. This point is also a point of the set of real number, which is the domain set of the function f of x. At this point, the value of the function on y-axis is f of x plus del x. This is the another point on y-axis. This point between these 2 points, there is a change in the dependent variable. This change is denoted by del y. This point is measured from the point y when we add the point del y, this change, this length with the point y, the next point which is denoted by f of x plus del x is equal to y plus del y, which is equal to y plus del y is equal to x plus del x whole is for n. This change is measured from f of x plus del x, and f of x plus del x is equal to x plus del x whole is for n. When we replace x by x plus del x, then the value of the function is calculated from x plus del x whole is for n and is denoted by y plus del y. And now we have to check, we have to calculate the change in the dependent variable. This change in the dependent variable is del y is equal to f of x plus del x minus y, or this is also equal to del y is equal to f of x plus del x minus f of x. This change is del y is equal to f of x plus del x minus f of x. That is, the difference between these 2 points is equal to the change in the dependent variable, which is denoted by del y. Now, this change in the dependent variable is due to the change in the independent variable. Therefore, we calculate the ratio between the change in the dependent variable with respect to the independent variable. Therefore, we divide this equality by del x, which is equal to del y divided by del x is equal to f of x plus del x minus f of x divided by del x. And now, applying limit as del x tends to 0 on both sides, we have limit del x tends to 0, del y divided by del x is equal to limit del x tends to 0, f of x plus del x minus f of x divided by del x. Now, f of x plus del x is equal to x plus del x whole is for n minus f of x is equal to x is for n as a whole divided by del x. And according to the condition of the limit, the function is in the form of f of x divided by g of x. And first, when the function is in the quotient form, and we have to apply the to calculate the limit of that function, first we have to write the simplest form of the function f of x divided by g of x as explained in our previous lecture. Therefore, we apply binomial theorem on x plus del x whole is for n. According to the binomial theorem, the term for this x plus del x whole is for n is equal to x is for n plus n divided by 1 factorial x is for n minus 1 del x, and so on. The last term of x plus del x whole is for n is equal to n factorial divided by n factorial x is for n minus 1 multiplied by del x whole is for n minus x raised to the power n is the whole divided by del x. Cancel del x whole is for n with del x whole is for n, and del x is common in each of these terms. Therefore, del x is common in each of these terms, and after the simplification, the result is n divided by 1 factorial x is for n minus 1 plus n multiplied by n minus 1 divided by 2 factorial x is for n minus 2 del x whole is for 1, and so on. N divided by n factorial divided by n factorial is equal to 1, and x is for n minus 0. N minus n is equal to x is for 0 is equal to 1 multiplied by del x whole is for n minus 1, and cancel del x. Now, this is del x. Del x cancel del x with del x. After the simplification, the apply the limit on each of these terms. We have limit del x to 0 n divided by 1 factorial x raised to power n minus 1 plus n multiplied by n minus 1 divided by 2 multiplied by 1 x raised to power n minus 2 limit del x to 0 of del x plus n into n minus 1 multiplied by n minus 2 divided by 3 multiplied by 2 multiplied by 1 x raised to power n minus 3 with respect to the limiting value is a constant. This is a constant with respect to the limiting value because only the limit only del x del x is only del x is in the range of the limit sign. The limit to only del x is in the range of the limit function. Therefore, x with respect to the del x is a constant. Therefore, push out del x to the power n minus 2 from limit side is n multiplied by n minus 1 divided by 2 multiplied by 1 is a constant. This is a strictly constant, and this function x to the power n minus 2 is a constant with respect to the limiting value. So only apply limit to del x. Similarly, n multiplied by n minus 1, n multiplied by n minus 2 divided by 3 factorial is strictly constant. This push out this quantity from limit side, and x raised to power n minus 3 is a constant function with respect to the limit value. Therefore, x raised to power n minus 3 push out x raised to power n minus 3 from limit side and apply limit to del x as a whole square, and so on. Apply limit del x to 0. Del x is a whole is power n minus 1, and after the simplification, the n divided by 1 factorial is equal to 1 multiplied by x raised to power n minus 1. This n divided by 1 is a constant. Push out n minus 1 from limit side, and x raised to power n minus 1 with respect to the limit function is a constant. Therefore, the limit of x raised to power n minus 1 is also equal to x raised to power n minus 1 plus n multiplied by n minus 1 divided by 2 multiplied by 1, 2 x raised to power n minus 2, and the limit of x raised to power 1 is equal to 0 plus n multiplied by n minus 1 n minus 2 divided by 6 x raised to power n minus 3, and apply limit to del x. Limit del x to 0, del x is equal to 0. 0 whole square is equal to 0 plus up to 1. In each of the term there is a quantity del x, and when we apply limit as explained in this term, when we apply limit to del x, the result is equal to 0. Then when we apply limit del x, 0 whole square, and each of the term there exists a function del x, and the limit of that del x with respect to del x is 0 is equal to 0. Therefore, each of the term is equal to 0 up to the last one. When we apply del x to 0, del x is equal to 0. Limit del x to 0 of del x is equal to 0. 0 whole is equal to n minus 1 is equal to 0, and which is equal to n multiplied by x raised to power n minus 1 plus 0 plus 0 plus 0, and each of the term is equal to 0, and add these terms 0 with n multiplied by n x raised to power n minus 1. The result is equal to n multiplied by x raised to power n minus 1. That is the derivative of y. Y in this case is x raised to power n is equal to n multiplied by x raised to power n minus 1.